Hello dear friends, welcome to this video in our YouTube channel. In this video friends, we shall be looking at one of those important problems in the 2013 Further Mathematics paper 3, that is Further Maths with Mechanics guys, which is based on probability distribution. So friends, please stay tuned and watch the entire video from start to finish. By that way guys, you're going to understand the concept. So it's some probability distributions. The first question is that the probability density function of a continuous random variable y is given by, this is what we have been given with the various intervals. We should show that k is equal to 1 over 6, and the Roman 2, we should show the probability of the absolute value of y is less than 1. We should evaluate this probability. Great. Okay, friends. Now, we should know that the clue of this question is what? Continuous random variable. Good. So these are just those special distributions. We have the binomial, we have the Poisson, the continuous, and so on and so forth. So guys, for a continuous random variable, the integral of the first function in this interval plus the integral of the second function in this same interval guys has to give us 1. Namely guys, the integral from -2 to 0 of k into y plus 2 dy plus the integral from 0 to 2 of 2k dy has to be equal to 1. Good. By so doing guys, if we integrate so well, if we integrate the first guys, k is a constant, we have k's outside, then integrating our function guys simply gives us 1/2 y squared plus 2y. Good. That's exactly what we have friends. Then now if we integrate, in fact guys, the limits of integrations are from, we are from -2 and they'll be ending at 0. Good. That's what we have friends. Then integrating the next 2k is just a constant, so we are just going to have y being multiplied to it, so we're just going to have 2ky. Limit of integrations guys are from 0 and will be ending at 2. Good. That has to give us what? 1. So friends, simplifying a bit by putting in the upper limit minus lower limit, we are definitely going to have 0 minus k into, we have -2 when we put in -2 and simplify, plus 4k. But minus k minus 2 is what? 2k, plus 4k gives us what? 6k. That therefore implies our 6k is equal to 1 guys. Good. We have 6k equal to 1. Dividing all through by 6 give us our k to be 1 over 6. Good. That's the first part guys, as required. So guys, the next part is now to find the probability that the absolute value of y is less than 1. Alright guys, we can simplify the inside by using our knowledge of absolute values, which simply means that this is going to be the probability of that -1, that y is between -1 and 1. Good. That therefore implies to get this thing done guys, we are definitely going to be looking at the definite integral going from -1 to 0, because guys, keep in mind that this our density function guys is defined in pieces. We want us to get from -1 to 1, but we need to get from -1, we end at 0, then we continue at 0 and we end at 1. Since the functions are defined in different the functions are defined differently. Okay, the intervals are not the same, so we cannot cross intervals when they are not integrated. So this is what we have guys. So integrating the first one guys, as we did here initially, we're just going to copy our integral that we have here. Good. So we are just going to have 1 over 6 is the value of k, which is the constant. Integrating this guys, as we did here guys, is simply 1/2 y squared plus 2y. Likewise here guys, integrating this guy, the limits here are from where? From -1 to 0. Then integrating the next guys, we are simply going to have 1/3 y. Limits again are from what? 0, and they will be ending at where? 1. Good. So if we plug in everything guys and simplify, we are going to have 0. That's where you put in the upper limit here guys. Upper limit, we are going to have 0 minus 1 over 6 into -3 over 2 plus 1/3. Simplifying everything guys gives us our answer to be 7 over 12. That's the answer friends. That's the answer. So friends, please subscribe to the channel if you've not subscribed, because you're going to miss out a lot guys if you don't subscribe. And please like the video and share it out with your friends so we can have more people to join us. Great. Let's look at the next part guys. Okay, great. The next part is the B part, reads that 5% of the students in a certain school study on scholarship. 60 students are chosen at random from the school. We should use the Poisson distribution to find to three-decimal place to three significant figures the probability that at least two of them study on scholarship. Okay, let's look at this part, guys. All right, so they want us to use the Poisson distribution, but friends, keep in mind that if they are not told us to use the Poisson distribution, we will just use the binomial distribution, since this is a binomial distribution, because we have the probability that 5% of the students study on scholarships. We have our P already to be what, 5%, then our cure is what, guys, 95%. So we have to use the Poisson to approximate this binomial. Good. So guys, we should let the number of students who study on scholarship be X. We are just like trying to define our random variable. Good. Then now, guys, for the Poisson distribution, the probability that X is the same like X is the same like e raised to the power negative lambda, lambda raised to the power X over X factorial. Great. This formula is found in our formula booklet, so you can easily open that and check. But we have to define what the value of the range of values that X is going to take. X, as you all know, guys, will take values from 0 to infinity. Great. From 0 to infinity. So friends, let's keep in mind that our lambda in this case is the mean, which is given as NP. Let's keep in mind that our N is the number of students who's that are chosen from the school, and P is the percentage of students that study on scholarship, or whether still it is simply the proportion of students that study on scholarship. So our N is going to be 60, P is 5%, which is going to be what, guys? 5 over 100. So this is what we have, guys. Simplifying everything, guys, gives us our answer to be lambda equal to 3. Great. We have lambda, guys. They want also find to three significant figures that the probability of at least two of them studying on scholarship. Friends, what does the word at least means? So guys, at least simply means that we have to get a probability that X is greater than or equal to 2. Good. Because at least includes 2. If they said at most, we are going to have less than or equal to 2. But now it's at least means from 2 and above. So we have P that X is greater than or equal to 2. Great. But friends, getting this result means we are going to start from 2 and end at infinity. But that is too much for us. Okay, we cannot even figure that out. But we can simply take 1 minus the probability that X is less than 2. Good. Okay, where X is less than 2, and that is simply going to save the task for us, since the sum of all the probabilities must amount to 1. So we're now going to be looking at the probability that X is greater than or equal to 2 be same like 1 minus the probability that X is less than 2. That therefore implies, guys, if we know for sure that if we want to start, we can either use our probability table, or we can simply plug in when X equals to 0 and when X equals to 1, guys. If we start plugging in when X equals to 0 and when X equals to 1, we are only going to have 1 minus we are going to have the probability at X equals to 0 plus probability at X equals to 1. If we plug in everything into where we have our P such that X equals to little x, we are definitely going to have 1. This is the 1 year minus the probability that X is less than 2. We are going to start plugging when X is 0. Plug in X equal to 0, 0 here. We are going to have lambda raised to power 0 is 1. E raised to power negative lambda, which is lambda is negative 3. So we have e raised to power negative 3. Plus, we do the same thing, guys. We're going to have 3 e raised to power negative 3. Simplifying everything, guys, is going to give us our answer to be 0.801. They said to three significant figures, guys. That's what we have. 0.801. Great. So friends, don't forget to like the video, friends. Please give it a thumbs up. That motivates me a lot to keep producing more great content. Thank you very much. Now friends, the Roman 2 is saying that 500 students are chosen at random from the school. They want us to use the normal approximation to calculate to three significant figures the probability that between 20 and 30 students inclusively will be studying on scholarships. Great. For instance, this question is very tricky and you have to pay attention, guys. It's very, very tricky. Let's handle it with care. Good. So, guys, in this case, you see that our n has changed, right? Here we're talking about 60. Here they're talking about 500. So our n has changed. That therefore means that our lambda in this case also has to change. Okay. Now, guys, to get our mu or our lambda or the mean or our new mean, guys, we can think that our new mean in this case is now going to be, we have 5 over 1000 times our new n, which is 500. Simplifying everything, guys, gives us an answer to be 25. Good. That's the value of our mu. Great. That's the mean. Keep in mind that our lambda in this case was the mean. Okay. Now we are using a different symbol such that you won't confuse lambda and the, so that you won't confuse between lambda and mu. Great. We have it with that. Okay. Now, friends, at this point now, we need to get our standard deviation. Keep in mind that, guys, this is a binomial distribution. Like I said initially, guys, it's a binomial distribution, and in such a case, guys, we need to get the value of our standard deviation, or we can get the variance and take the square root to give us the standard deviation. But we can get the standard deviation by simply saying that our standard deviation, guys, is simply going to be the square root of NP cure, where our cure is simply the probability of failure. Keep in mind that 5% is a probability that a certain student study on scholarship. We can call this probability of success. Then the probability that a student does not study on scholarship is simply just going to be one. It's simply just going to be, since they're dealing in this case with in percentage, we'll take 100% minus 5%, which gives us 95%. So plugging everything, guys, we are going to have n, as you all know, guys, is what's our n, guys, is 500, right? Then our p is what, guys? Our p is 5. Sorry, our p in this case, guys, great, is what, guys? 5. Good. Then our lambda is what, guys? 25. So if we plug in everything, guys, we are going to have the square root of 23.75. Great. That's what we have. Then, friends, we should, that's, since we now have our standard deviation, in this case, guys, we can simply use our knowledge of the normal approximation by simply saying that since the question was talking about from 20 to 30, right, inclusively means the boundaries are included. So we are simply trying to get the probability of what, from 20 to 30 inclusively. Okay, now, friends, since we are trying to use the normal distribution to approximate a binomial, we need a suitable continuity correction. So, friends, from the continuity correction that we all know, since the boundaries in this case are included, we are going to remove 0.5 from the first interval and add to the second. By so doing, guys, we are going to be looking at now the probability from 19.5 less than x less than 30.5. Great. That therefore implies, guys, okay, now at this point, we know that our mean and standard deviation are not 0 and 1, right? Are not 0 and 1. So we now have to standardize it. By so doing, we are definitely just going to have the first interval minus our new mean all over the standard deviation, all over our standard deviation, guys, which is the square root of 23.75. Then now we do the same thing in the upper interval. Let's figure it out here, guys. We are definitely just going to have 19.5 minus 25 over what we have. Great. This is what we have, guys. So if you simplify everything, guys, we are going to be looking at the interval now from negative 1.13 less than x less than positive 1.13. Good. That is to 2 decimal place. Okay, now, friends, let's try to look at how this guy looks like. Okay, let's look at how this our interval looks like on our normal on the normal curve that we all know. Let's look at it. Let's just see a small sketch. Good. This is how it looks like, guys. Let's call the first interval phi of x. The next interval can still call it phi of x. So here it's going to be negative 5x. Let's look at those regions, guys. we locate the first region, that is minus 5x. Then the positive region, which is 1.13, we can call that positive 5x or just 5x. Keep in mind, friends, that this entire area under this our graph is equal to what? Is the same as what? 1. Good. So friends, and the area in which we are looking for is simply the one I'm shading. Good. That's just it, friends. That's great. Awesome. That therefore implies, guys, if we simplify our expression to get this area, we'll see that this is just the same like 2 phi of x minus 1. Our phi of x, guys, from our probability table is simply going to be what? It's simply going to be 0. It's simply going to be our 0.8708 times 2 minus 1, and that gives us our answer of 0.742. Great. Thank you so much, and see you in my next video, guys. Subscribe to the channel if you want more great content, and have a blessed day.